Hey guys, Mr. Milton here. Today we're going to look at graphing functions notes. At the end of this video, you should be able to graph a function using a table of values, and you should be able to identify the shape of a graph before graphing it. Okay, let's jump right into it because we've already established a lot of these rules in our previous lessons, or a lot of these skills in our previous lessons. Now we're kind of just putting it together. So the first one says graph each function on the given coordinate plane by plotting at least 5 points from the table of values. Here, f of x equals 3x minus 4. Okay, so what we're going to do as we graph this is we're going to make a table of values. And so our table can be very simple. Just a T table. Okay, here's my X, here's my Y. Okay, and you guys know that the X values are called the independent variables. Okay, you might also call them input. You might call them the domain. You might just call them X values, but all these are important. I want to focus on independent. Okay, and it's called independent because nothing's stopping it or controlling it. Okay, and you can think of independent as doing what you want. Okay, and with the X values, you do what you want. You choose the values that you want to choose. Okay, and I always say that you still want to make good choices when you're independent. Okay, a lot of times children can't be independent because they need ice cream for dinner. Okay, and end up sick because it's a bad choice. Okay, so we want to make sure that we're not making our math sick because we're making bad choices. Okay, and so here are the rules that we want to use when making our choices with our graphs. Typically, we want to see how our graph functions when it's the value's negative, when it's positive, and we want to keep the numbers manageable. Okay, so small if possible. Okay, and we also want, if we can help it, to get whole numbers, nice solid numbers. So we try to make choices to make those things true for our final answer. Answers, outputs. Okay, and so typically what we can do, if there's no fraction or anything, we'll just say, hey, if we need to choose 5 values, let's choose some low values that are negative and positive. And so we'll choose these numbers, -2, -1, 0, 1, 2. Okay, and then we'll just plug them in and see how they function. So 3 times -2 minus 4, that gives me -6 minus 4, -10. Then I'll do the same thing, except now instead of using -2, I'm going to use -1. 3 times -1 is -3, minus 4, -7. Do the same thing with 0. 3 times 0 is 0, minus 4 is -4. Don't really need to calculate that a whole lot. 3 times 1 is 3, minus 4 is -1. And then finally, 3 times 2, 6, 6 minus 4 is 2. And so I've made a table of values using this function rule. And so then I go through and I plot what I can. So even though I made this rule -2, -10, 1, 2, 1, 2, 3, 4, 5, 6, 7. It's not going to fit on my graph. I don't have to try to make it fit. It doesn't fit. -1, -7, 1, 2, 3, 4, 5, 6, 7 fits. 0, -4, 1, 2, 3, 4, 1, -1, 2, 2. 2, 2. Okay. Okay, and so here is our table. I guess we could continue on. But here, we made our table of values. It has 5 values. We're good. Down 3 over 1 up 3 over. I feel like I messed up, though. I messed up 6 minus 4. 1 is 3 minus. We should go to do 0, -4, 1, 2, 3, 4, 1, -1. Okay, -2. Huh. Like this isn't right. 2, 2. That's why. There we go. I knew it didn't look right. I said 2, 2, and I should put it at 2, 2. All right, looks a lot better. All right, and so I'll follow this graph. It should just try to make a straight line. All right, and it should be a line. My hands weren't so shaky. It's just a line. Connect those things. Okay. What shape is it? Just a line. Okay. Here we have 1 minus 2x. Again, we're going to do the same thing. Again, no fractions, so nothing stopping us from just using that -2, -1, 0, 1, 2. Get positive, we get negative, we get low numbers. Should be good. X, Y. So -2, so 1 minus 2 times -2. And that is +4, so 1 plus 4, 5. Okay, do the same thing here. And now it should be -1. -2 times -1 is 2. 1 plus 2 is 3. Great. Same thing here with 0. 1 minus 0 should be 0. So, 1 minus 0 should be 1. Wow. Okay, and you really should notice a pattern here if you're looking at it and you're saying, hey, every time we increase by 1, this increases by 2. And so we can kind of follow that pattern if you like and say, okay, that should be 3. That should be 5. Nope, it decreases by 1. I'm saying that the wrong way. Decreases by 2. So we should say, hey, this is -1. This is -3. Okay, but that's the same thing that we'd find out if we plug these values in as well. Okay, so we'd have 1 minus 2, which is -1. We'd have 1 minus 4, which is -3. Okay, and so now we plot our points: -2, 1, 2, 3, 4, 5. -1, 1, 2, 3. 0, 1. 1, -1. 2, -1, 2, 3. All right. Try not to mess up 2 times. Well, it's a lot harder to make a straight line on the computer. All right, so here we go. There's our arrow. Boom, there's our graph. What's the shape? It's a line. Looking at this, 1/2 x, x, y. Remember that we said that the independent values, we can choose what we want, but we want to make sure that it helps us out, right? And so here, I notice in this problem, I have a fraction, okay? And so if I chose -2, that's not a bad idea because 1/2 times -2 gives me -1. But if I chose -1, now I have a fraction. I have to find a place to plot 1/2. I don't really like that option because I don't know where 1/2 is exactly. Like I can give it a guess, but why? And so this is independent, and so I can choose what I want, okay? And so now I'm going to say, well, my denominator is 2. I'm going to choose values that are divisible by 2. So instead of choosing -2, -1, 0, 1, 2, I'm going to say, well, if I make all my numbers even, then all of them will come out as nice numbers. So I'm going to do -4, -2, 0, 2, 4. Okay. And so now that I plug that in, 1/2 times -4, -2. 1/2 times -2 is -1. 1/2 times 0 is 0. 1/2 times 2 is 1. 1/2 times 4 is 2. And so now, because I used my independence wisely, I got good outcomes. Okay, so -4, 1, 2, 3, 4, -2, -2, -1, 0, 0, 2, 1, 4, 2. And so we should have our line go through these points. And so as we look at this next one, we're looking again at our denominator here because we have a fraction. We want to say, okay, how can we make sure that our numbers come out nice? And so just like we did last time, and last time we said like, oh, they're even, but really, remember, even just means a multiple of 2, okay? And so because our denominator is 3, we want our independent, again, we get to choose these values to come out and be multiples of 3 so that they come out even. And so now I'm going to choose, instead of -2, -1, 0, 1, 2, -6, -3, 0, 3, 6. Plugging those values in, seeing what I get out. 2/3 times 6, so that'd be -12 over 3. So -4 minus 4, or sorry, -1 is -5. Okay, -6 divided by 3 is -2. -1, -3. 0 minus 1 is -1. 6 over 3 is 2, minus 1 is 1. 12 over 3 is 4, minus 1 is 3. Okay, and as we go through, plot these points, -6, -5, -3, -3, 0, -1, 3, 1, 6, 2, 3. Okay, and so our line goes through here. And I didn't answer that for the last question, but I said it was a line. This was a line. This was a line. Line for both of them. Notice how we chose these values, and we talked it through. -2, -1, 0, 1, 2 for our values for x. And for problem 3 and 4, we chose different x values because those had fractions being multiplied. Don't need to change colors. Because they have fractions multiplied into the variable. To get clean numbers, we chose multiples of the denominator. Denominator. So we've already talked through all that stuff. Rewind if you need to hear back why we did that. Okay, notice all these are lines. Okay. All 4 of these problems made a line. These are absolute value functions. Absolute value functions. So we're just plugging these in. Remember the absolute value bar, all that does is make whatever comes out of this thing become positive. Doesn't change anything that we do inside. So here we have to plug in our values. There's nothing again stopping us from just using -2, -1, 0, 1, 2. So I'm going to use that, keep my numbers low, get to see how it reacts to positive and negative. Okay, so -2 plus 2 is 0. Absolute value of 0 is 0. -1 plus 2 is 1. Absolute value of 1 is 1. 0 plus 2 is 0. Sorry, 0 plus 2 is 2. Boom. 1 plus 2 is 3. 2 plus 2 is 4. Okay, so as we plug these values in, okay, look what happened. We have -2, 0, 1, -1, 1, 0, 2, 1, 3, 2, 4. Okay, you might say, oh, this is going to be another line too. Well, here's the importance of understanding what our shapes are going to look like. Okay, we just looked at a whole set of lines, and we said, hey, how could we tell that they look like lines before and they just had x? Here, these don't just have x. Okay, these are absolute value functions. Okay, and when we see an absolute value function, we understand, hey, absolute value functions probably aren't going to look the same as lines, and really, we'll see what they look like in just a little bit. But we want to make sure that we find the center of this function. Okay, and we'll actually use some different numbers. Let me plug in -3 and -4 here. Okay, let's see how that looks. I know it's out of order, but let's see how that looks. -3 plus 2 is -1. The absolute value of that is 1. -4 plus 2 is -2. Absolute value of that is 2. So when it's -3, 1, -4, 2. Okay, looking at our pattern, we should say what we expect for our graph to do as it continues this way. Well, we expect it to continue to rise this way as it had, yeah, and this way. Okay, what shape is this? It's a V, V-shaped. Function here, plug in our values. Again, there's nothing really stopping us from using the values that we typically use, so -2, -1, 0, 1, 2. Plugging in those values, notice that there is a negative out here. So 2 times -2 is -4. This should be positive, but the negative that's -4 plus 3 will give us -1. Okay, -2 plus 3 is 1. 0 plus 3 is 3. 1, so that'll be 2. -2 plus 3 is 1. And then this will be -4 plus 3, which would be -1. Plugging this in, We have 0, 3, 1, 2, 3, 1, 1, 2, negative 1, negative 1, 1, negative 2, negative 1. And look at this. So it's an upside down B. Okay. And now you might look at this and say, oh, wait a second. These are both absolute values. Why is this one upside down? And hopefully you think next, maybe this negative has something to do with that. This negative outside of the absolute value bar turned it upside down. Okay, so with the absolute value, we see that the absolute value bar makes it a B. The negative outside of it makes it go upside down. Okay, number 7, values X and Y. Nothing's stopping us from using these values, 0, 1, 2. So I'll plug it in. Notice that there's a negative already here. So when we square our values, we got to make sure it becomes negative. So 2 squared, 4, negative 4 plus 5 is 1. 1 squared is 1, negative 1 plus 5 is negative. All right, it's 4. All right, there. I am 0, easy. 1 squared, negative 1, so 4. And then 2 squared is 4, negative that. It's going to get negative 4 plus 5 is 1. So our values here then, negative 2, 1, negative 1, 4, 3, 4, 0, 5, 1, 4, 2, 1. Okay, and so we have this graph. You'll notice it's in a straight line like the last one was. Okay, it's a U-shaped curve. Okay. All right, and we'll look at this one. And if you looked at this in the beginning, you're like, wait a second, there's a fraction by our variable. So we want to make sure we get numbers that let our fraction come out as a whole number. And so I'm going to choose, instead of negative 2, values of multiples of the denominator in this case, which is 2. So instead of negative 2, negative 1, 0, 1, 2, I'm going to use negative 4, negative 2, 0, 2, 4. And then plug those in. And there's a positive here, so 4 squared is 16, times 1 half is 8, 8 minus 4 is 4. Negative 2, 2 squared is 4, half of 4 is 2, 2 minus 4, 2. Yep, 0 minus 4, negative 4, 2, plugging that in will be the same, 16, 1 half, 8, 4. Okay, and so now, making our graph 0, negative 4, 1, 2, 3, 4, 2, negative 2, 0, nope, I already did that, 4, 4, 1, 2, 3, 4, okay, negative 2, negative 2, and negative 4, 4, 1, did I do 4, 4? That's crazy, 1, 2, 3, 4. I set 4, 4 and plotted it at 4, 0. 4, 1, 2, 3, 4. Okay, and so now making sure that my graph matches up to my table. Connect my points. Okay, and that is try to be a U-shaped curve. Okay. Again, you'll notice that, hey, one U's up and one U's down, and hopefully you'll say, oh, negative. That negative caused it to go upside down. Okay, so 5 and 6 had a V shape because of the absolute value around the variable, and 7 and 8 had a U shape because the variable was squared. Any other exponent will give the graph a different shape. The V shape and the U shape are upside down when the coefficient is negative, as we highlighted in the green. Okay, so all that is so we understand what a graph should look like before we graph it just by looking at the function. And this is important, again, for us to be able to check ourselves. Remember that when we were doing problem number 5 up here, of f of x equals f sub a of x plus 2, we knew that we couldn't just do a line even though we had plugged 5 values in because it didn't look like the other line functions. Okay, so understanding the shape helped us out with that. So here, as we look, y equals 1/3 x minus 5, we'll say, wait, it's just x. This should be a line. If I get something else than that, then I know I need to double check myself. Number 2, we have x squared. Okay, so we say this should be U-shaped. Okay, absolute value, this should be V-shaped. This is just x. This should be a line. Okay, actually, and I say U-shaped, but look, it's like here, there's a negative in front of this. I should say upside down. Just to make sure, upside down U-shaped. All right. Okay, guys. Thanks for sticking around. See ya.